Hello, and welcome to Daily Coding Tips. Today's tip, Async I/O, using async and await for concurrent operations. When performing I/O operations, like reading from a network or a file, your program often waits, blocking other tasks. This can make your application unresponsive. Traditional synchronous code handles these operations sequentially, leading to inefficiencies, especially in network-bound applications. Asyncio lets you define coroutines, functions that can pause and resume execution, using async and await. Await allows a coroutine to temporarily relinquish control, allowing other coroutines to run while waiting for an I/O operation to complete. This enables concurrent execution without threads. The async keyword transforms a regular function into a coroutine function. Inside a coroutine, you can use the await keyword to pause execution until the awaited operation completes. This ensures that the event loop can switch to other tasks, preventing blocking. Asyncio allows you to perform multiple I/O-bound operations concurrently, rather than sequentially. This drastically reduces the overall execution time, as the program doesn't wait idly for each operation to complete before starting the next, resulting in faster and more responsive applications. Unlike threading or multiprocessing, Asyncio doesn't rely on creating multiple OS-level threads or processes, which consume significant memory and CPU resources. Asyncio utilizes a single-threaded event loop, making it more lightweight and efficient for handling a large number of concurrent operations. Asynchronous web frameworks like AIO HTTP and Fast API use async to handle multiple incoming requests concurrently. Instead of blocking while waiting for database queries or external API calls, the server can switch to processing other requests, improving throughput and responsiveness. Asyncio is well suited for handling real-time data streams, e.g., from sensors or message queues. You can asynchronously read data from multiple sources and process it concurrently, ensuring that the application keeps up with the incoming data flow without blocking. Python 3.11 introduced Asynchronous I/O Task Group, which simplifies managing multiple related tasks. Using a task group will automatically wait for all the tasks within the task group to complete, and propagates any exceptions that may have occurred in the tasks. Async I/O allows you to cancel running tasks using task.cancel. This can be useful for implementing timeouts or gracefully shutting down the application. It's important for the coroutine to properly handle the canceled error exception to release resources. Avoid making blocking calls, example time.sleep, blocking I/O directly within asynchronous coroutines. These will block the event loop, negating the benefits of Asyncio. Use asynchronous alternatives like async.sleep or asynchronous I/O libraries. Thanks for watching. Subscribe for daily coding tips and hit the like button if this was helpful.